Today we're going to talk about complex circuits. So here's an example of a complex circuit and the task you might have to do. We see a 6-volt battery, a 4-ohm resistor, and a 7-ohm resistor that are connected to each other, and then above it this 3-ohm resistor. The prompt says find the voltage and current through each resistor, find the equivalent resistance of the battery and the current coming from the battery. So we want to figure out how to analyze this circuit. It isn't series or parallel, right? These two are in series, but then this is in parallel with it. So what we have to do is collapse it down in steps. So a rule of thumb for collapsing circuits is that if we can draw a circle around 2 of the resistors and then only 2 wires come out, we can collapse those into one equivalent resistor. So if we look at this picture again, if I draw a circle around these 2 wires, these 2 resistors, I have 1 wire coming out here, 1 wire coming out here. So I can collapse these 2. If I draw a circle around these 2 resistors, let's say I get a wire, 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 that's no good, that's 3 wires. So what I'll have to do is I'll have to collapse these first, or find the equivalent resistance of these 2 first using series rules, and then take this equivalent resistor and add it with this one using parallel rules. So we'll start by collapsing the 4-ohm and 7-ohm resistors in series, this one and this one, and we get the equivalent resistance here to be 11 ohms. The next step then is our original picture looked like this. Now we have a new circuit that looks like this, so we want to find the equivalent resistance of these 2 resistors in parallel, so we'll use our parallel rules. 1 over the equivalent resistance is 1 over 3 plus 1 over 11. So that gives me an equivalent resistance of 2.36. And so this is, let me go back up since it's awkwardly cut off. This is kind of our final picture. This is what the battery feels, right? Since the battery can't look out and see what resistors are connected to it, this is the equivalent resistance, or the resistance that the battery experiences. So now that we've fully collapsed our circuit, we can figure out, ultimately we want to figure out the current through each resistor and the potential difference of each. So we know the equivalent resistance. Now we can figure out the current of the battery using Ohm's law. So we know the voltage of the battery, we know the total resistance, and so we get the current coming out of the battery is 2.54 amps. We also know that because this resistor is connected directly in parallel with the battery, we know that its potential difference is 6 volts. So we know V, we know the resistance is 3, so we can get the current, and this is going to be the current through this resistor of 2 amps. That means the current through these resistors must be the total current minus the current through this one. So 2.54 minus 2, or 0.54 amps. So that's the current through the 11 ohm equivalent resistor, but that's also, because these are in series with each other, the current through the 4-ohm resistor and the current through the 7-ohm resistor. So then we can figure out the potential difference across the 4-ohm resistor, taking the current through it times its resistance, and that gives us 2.16 volts, and then the potential difference across the 7-ohm resistor, taking the current through it times its resistance, and that gives us 3.78. We should get that these 2 values add up to 6 because they're connected together directly to the battery. And you get close, you're a little off due to rounding as we go through. So that is complex circuits. Take a look, practice a few, let me know if you have any questions.